Well, good afternoon, scholars. This is Mr. Larson. We're going to be talking about some linear equations once again, but before we do, a cartoon from Life at McPherson High by John McPherson. What you'll notice is there's a father here. And, okay, open the door just like you would any other door. Good, good. Keep going. Pretend I'm not here. Perfect. And the caption down here is, as soon as his dad bought the video camera, Eric knew that the first day of school would be a catastrophe. Poor guy. I wonder if you've felt that way before. Thanks for smiling. Hey, if you have any questions from yesterday's lesson, you should email me, and then we'll figure out how to get it answered. Either we do it in our live meet, or I would produce a video that would be uploaded, or something. We have to figure this out, how we can get questions answered, and I'm not exactly sure how it will take place now. But just know that if you have questions, you have to ask. In this lesson today, our learning target is, I just want to remind you about three ways to write equations of lines. One's the slope-intercept form, another's called point slope, and then it's one other way dealing with 2 points that you're given. So anyway, let's get going. We're going to talk about writing equations of lines. And this is a snip that I took from your textbook. Remember, slope-intercept form looks like this, where M stands for slope and B is the y-intercept. And in this so that is one way. If you're given the slope, you're given the y-intercept, just plug it into an equation, graph it, and you're done. There are times, though, that the problem won't be that direct. That's the easiest way. Another way to do it is sometimes the problem will say, hey, I'm going to give you the slope, and I'm going to give you a point. You figure out what either the slope-intercept form is or the standard form of the equation. So that's another way, and that is called the point-slope form. And then the third way is, if you are given 2 points, you could, first of all, solve for the slope, and then use the slope and one of the points. It could be either of them. Either of them will give you the same equation of the line, and plug it in and find out what the values that are missing are, and you'll go from there. A couple other things that I want you to remember as we get ready for this lesson. When we have parallel lines, what you will notice is that the slopes are exactly the same. They're equivalent. And for perpendicular lines, you also should remember that instead of being exactly the same, perpendicular lines are negative reciprocals of each other. In other words, when I take a slope of 4 and a slope of negative 1/4, those two lines would form a 90-degree angle in a coordinate axis system. Because the test is, you take the one slope times the other slope, and if it equals -1, they are perpendicular. So let's start with an example. 2 lines are parallel if they have the same slope. Remember that. And the example is, I have this equation, and I know they are parallel because my slope is -3. So what we want to do is write an equation of the line that passes, this was just an example up here. We're going to move on to another example that starts this way. Write an equation of the line that passes through this point right here and is parallel to that line. So what we do know is that the slope that's parallel to this line has to have a slope of -2. Because we learned up here, these two lines were parallel because they had the same slope of -3. So down here in this problem that we're looking at, what we can say right away is, well, the slope has to be -2. So we're just going to use that first way to get an equation for the line. I know that the slope was -2. So I am going to go y equals mx plus b. And I'm going to put my slope of -2 in that equation. That really can't, that is the equation of a line that has the slope of -2 and a y-intercept of 6, but we don't know if that is exactly what's happening here. So we have to take it a step further. What I'm going to do is I'm going to replace the x and y here and here with the x and y in this ordered pair. Then the line that has the slope parallel to this line and goes through this line will be what I find. And so we're set with that. So what I'm going to do is where I see an x right here, I'm going to put in a -3. Where I see the y right here, I'm going to put in the 3. So I'm just going to solve it for this value over here, b. It looked like a 6 earlier. I'm sorry if I misidentified that. So 3 equals -2 times -3 is a +6 plus b. And so what I'm going to do is I'm going to subtract 6 from here and there. And what I end up with is my y-intercept, the constant, is 3 minus 6, or -3. And so to write in slope of intercept form, the equation that I'm actually looking for has a slope of -2, because that is the same as the one up there. But in this case, the y-intercept is 3. So what we'd find if we'd graph these things quickly, this one right here has a y-intercept of 1, and the slope is -2 over 1. So I go down 2 and over 1. I draw the line. And so this is y equals -2x plus 1. The other one, -2x minus 3, the y-intercept is 1, 2, 3 down. And then the slope is still the same, down to 1, 2, and over 1. So I draw that line. And I didn't do it real precisely, and so they don't look like they're perfectly parallel, but I just sketched it kind of off the cuff, and that's what, but they should be exactly the same distance apart everywhere. That's the definition of parallel. So, so the other thing that we talked about was that two lines are perpendicular if they form a right angle when they intersect, and the slopes are negative reciprocals of each other, or opposite reciprocals. So you'll notice in this example right here that this line has a slope of 2, this one has a slope of -1/2. They are negative reciprocals of each other, so we know that they're perpendicular. So let's look at a problem. Write an equation of a line that passes through 4, -2, and is perpendicular to this line right here. Well, let's start by identifying the slope of the perpendicular line. So this one right here. If this has a slope of 4, any line perpendicular to y equals 4x plus 2 has to have, think about it, say it, write it down. I hope that you wrote this, -1/4. The slope of the line perpendicular to this one has a slope of -1/4. Now, I have a point, I've got the slope, I can do what I did in the last problem. I'm going to write y equals mx plus b, as in boy, it's not a 6. And what I'm going to do is I'm going to plug in the slope of -1/4 here, and here's my x value and here's my y value. So I'm going to put those in here and here. And so this was times 4, and this would be -2. And so what I'm really doing, I just am essentially finding out what is this b equal to. What's -1/4 times 4/1? Hopefully you said -4/4, which is just -1. And then when we add 1 to both sides, I end up with b equaling a -1. So what that tells me then is the slope-intercept form of the linear equation that's perpendicular to this one right here looks like this. -1/4, that's where I just replaced the m, x plus the value of b that I found down here, and it's easiest for us to just say -1. This is the equation of the line that is perpendicular to that line right there and goes through this point up here. Okay, now one of the last problems that we're going to look at is where we're going to find the slope. We're going to use either of these points to write an equation in this form. So it's going to look like this. You may remember seeing an equation that looks like this. The slope is the rise over the run. Rise is a vertical or a downward direction. The run is across. And so another way to write the equation for slope is y2 minus y1 over x2 minus x1. That's something that you probably should have in your notes. So we're going to find out, and let's just call this x1, y1, x2, y2. Sometimes it's good for you to label it just so you don't get things mixed up. So I'm going to take this 1 minus a -3, y2 minus y1, and I'm going to put that over x2 minus x1, which is 3 minus 1. When I simplify that, 1 minus a -3 is like 1 plus 3, so I get 4 in the numerator. 3 minus 1 is 2. So what I end up with for the slope ends up being 4/2 or 2. So I know that. Then what I can use is this form of the equation once again. And I'm just going to plug in the 2 where I see the slope. And remember, this is b as in boy. And I'll just take either of these. I'll take this one, x1 and y1. So I know this is going to be 2 times 1 equals that -3 plus b. So then this ends up with b plus 2 times 1 is 2 equals -3. When I subtract 2 over here, it looks like b is going to be equal to -5. So to wrap this up, I know that the slope is 2, y equals 2x, and I know the y-intercept is -5. So this is the equation that has the slope that is described by these 2 points. When I found the slope of the line that connects those 2 points, it was -5. Pardon me, the slope was 2 and the y-intercept was -5. So that is our solution there, y equals 2x minus 5. Okay, a couple more problems. I thought we were getting close to the end, but here we go. Write an equation in standard form of the line that satisfies the given conditions, and remember standard form is this, where we have coefficients in front of the x and y, they're on the same side, and it's equal to the numbers that don't have variables or the constants are on the right side. So I know that the slope is negative 1/4. I want it to pass through there. Okay, so let's plug it into the y equals mx plus b. That's the kind of quickest, most direct route. So I'm going to put a negative 1/4 in where I see the slope of m, or a symbol for slope, m. And then this is going to be my x value, and that's in my y value. That's always the order that ordered pairs are in. So I'm going to take this times negative 1 plus b, and that's going to be equal to 5. So negative 1/4 times a negative 1 is a positive 1/4. And so in order to get b all by itself, I'm going to subtract 1/4, subtract 1/4, and it looks like b equals, if I have 5 over 1, that is really the same as 20 over 4. I multiply both top and bottom by 4. If I take 20/4 minus 1/4, that is the same as 19/4. So y equals negative 1/4 x plus 19/4. That's the slope-intercept form. But if we actually want to find out what the standard form is we have to do something to get rid of those fractions. And one of the principles that you might remember is the multiplication property, that if you do something to one side of an equation, you have to do it to the other side. And so what we can do is, I'm going to multiply this entire, I'm putting brackets around the whole equation. If I multiplied it times 4, that's going to eliminate all of those fractions. And what I end up with is 4 times y. It's like I'm distributing this here, here, and over here. So 4 times y is 4y equals 4 times a negative 1/4 is actually a negative 4 over 4, or negative 1x, plus 4 over 1 times 19 over 4 is actually, what is that, 76 over 4, because I take top times top, bottom times bottom, 76 over 4, which is really just 19. And so then to finish this off, I just add x to each side, and what I end up with as a standard form is x plus 4y equals 19. So that is kind of a little messy, especially because we have those fractions in them. They kind of get messy. So that's an example I wanted you to look at. Okay, the last problem. In chemistry, in a chemistry experiment, you record the temperature of a compound to be -5 1 minute after you begin the experiment. That's given by this ordered pair here. Time 1 minute after is -5. And 6 minutes after you begin the experiment, the temperature is 20 degrees Fahrenheit. So 6 minutes later, that's the time, the temp is 20. Write a linear equation that models the temperature of the compound as a function of the elapsed time. So we're going to do exactly what we did in the previous example, but this is in a one that is really relevant, and you can apply it to something like a chemistry experiment. So remember, we started by finding the slope, and we used this equation where I determine, let's say in this time, this is going to be x1, that's y1, this is going to be x2, that's y2. So I'm going to start by finding the slope. The slope of these two ordered pairs, if I was to graph them on a coordinate axis system just to get a visual picture of them, I want to know what the slope is. I end up with -5 minus 20. That is all over 1 minus 6. And so what I end up with is -5 minus 20 is a -25. 1 minus 6 is a -5. When I simplify this, it looks like I just end up with a positive 5. I've got a slope of positive 5. Now, what I want to do is put it in a form that is easy. And I always go back to this. What I know is that my slope is 5, but I don't know what the y-intercept is. So let's plug in either of these points, either the 1, -5 or 620. Let's try the 620 in here. And so I know that the y value is 20 equals 5 times 6 plus b. Well, 5 times 6 is 30. So if I subtract 30 from both sides, it looks like my value for b is going to be, this is 0, 20 minus 30 is -10. So what I end up with is an equation y equals 5x minus 10. That is the equation that describes the temperature rising in this experiment. And we're just going to write a linear equation that models the temperature, and so we did that. If I was to be asked to put it in standard form, there'd be one more step to it. I'd subtract 5x from both sides, and I'd end up with an equation in standard form that looks like this. Great. Thank you for listening. You're going to be working on this on your own on a worksheet. It's called Write Equations of Lines. It's in your Wednesday folder. Remember, what we've been talking about is just figuring out how to write different equations of lines using several different ways, and I've modeled that for you. Now it's your chance to practice on your own. Thanks for